Yeah. Hi guys. Hi. Hi guys. Hi to the sir as well. And today my group is going to explain the heart and lifestyle data analysis. And first I will introduce my group and Beam Arjun, Bharat, Sanjay, and my name is Pavan. And here, my group is going to explain health and lifestyle data analysis, and what we are going to explain in this study means, and so look at house lifestyle and demographics and psychological affected by health, and which outcomes like diabetes and heart diseases. Yes, and we are going to explain this part in this presentation. Yeah, and this is the abstract. And in this project, we used a data set, and which is taken from the Kaggle, and we cleaned the data set and exported the data, and tested by key hypotheses, and also tested and also built predictive models. We evaluated models like logistic regression and random forest KNN and SVM, and which are using metrics such as accuracy, precision, and recall F1 score and ROC and AUC. And this is abstract. And the next slide, these are the contests, and we are going to explain in the deep way, one by one. Yes, and from this slide, this is the main part of the project of our project and introduction, and means what we are going to explain in the introduction and lifestyle factors like smoking, alcohol, exercise, and diet, and which are combined with demographics such as age, gender, and psychological measures like BMI and blood pressure, and which have a major impact on health. And in this project, our main aim is to study the relationship between the build predictive models. And after completion of this one, next slide. Yeah, data acquisition. Yeah, means what is the data acquisition means is the part, and we took the data set from the Kaggle, and from the data set which is explained by the health and lifestyle data set. Yes, and it includes demographics, and I will give two examples of demographics and age and gender. And next one is the lifestyle variables, and lifestyle variables includes like heart disease, weight, height, and heart rate, and what I can say, hours of sleep. And again, and psychological measures also there. And I can say I can include also health outcomes such as diabetes and heart diseases. And from the next slide, my friend Bharat will be continue. Thank you.
Yeah, in the data pre-processing, we cleaned the data set by fixing missing values with median or mode instead of dropping them, and checked for outliers using box plots, and converted categories like gender and smoking into number for analysis, and scaled continuous values like BMI, BP, or so model treat them fairly. And in short, the data was cleaned, encoded, scaled, and summarized before analysis. Uh, Next slide. Uh, in this descriptive analysis, the bar chart shows that most people are non-smokers, non-diabetics, and without heart diseases. The pie charts of bed pleasures show that above 60% have BP above 120 by 80, meaning many in this group are at risk. These charts confirm that most people are healthy overall, but many have high blood pressure, heart diseases cases showing high BP, and BP also increases with age. Can you go to the next slide? In these images, the bar chart shows counts of categories most people said no for smoking, diabetes, and heart diseases. The gender chart shows more males than females in the data set. This image is highlighted class imbalance for favor people with heart diseases. These charts show that distribution of each variable. Most are non-smokers and healthy, more men than women, and blood pressure is high for many. The imbalance is heart diseases cases in important for how we evaluate model. And I will give next slide for Beam.
Thank you, Bharat. Yeah, so moving ahead to further EDA. So we come with heart disease distribution, and we found that the heart disease distribution was around 90% of people didn't have heart disease based on our data set, and only like 9.3% were having heart diseases. And in terms of count, we found that around 1,000 people were there who didn't have heart disease, and around 100 people had heart diseases. Next slide. So in the next slide, we can see that the blood pressure distribution, and we can see that percentage of individual, and we found that high blood pressure people were around 60 percentage, and the low blood pressure were 40.3 percentage, and for the normal it was 0.1 percentage. And in terms of gender distribution, we found that male distribution was slightly higher than female, which is like 88% for male and 42% for female. Yeah, moving ahead to the next slide, we did hypothesis testing for further analysis, and we particularly choose three hypothesis testing. First is smoking versus heart disease. Second is diabetic versus calorie intake. Third is alcohol consumption versus by smoking group. We perform chi-square test first hypothesis smoking versus disease, since both of them were character variables. And for the second one, diabetic versus calorie intake, we did it in t-test because both of the value were in numeric variable. And for the third one, we did one way ANOVA. Moving ahead to the next slide. Um, yeah, so for the predictive analysis, yeah, so after this, we are going for the predictive analysis. Since our target variable is heart disease, which should have binary value of yes or no. So we basically build four models. One is logistic regression, one is random forest, third is k nearest neighbors, KNN, and fourth is support vector matrix, SVN. So after building all the models, we done some pre-processing as well. So we basically encoded the labels for categoricals and standardized the continuous feature to build our model and to do the further analysis. For the upcoming part, I'd like to hand over to Sanjay. Thank you.
Hello guys, so here is the result of our analysis of the health and lifestyle dataset. We perform the variety of statistical tests such as chi-square test, t-test, and ANOVA test. And for the relationship between and heart disease, here both are the categorical variables. So we choose the chi-square test to show the relationship between them. Here the null hypothesis is smoking status is independent of heart disease, and the alternative hypothesis is smoking status is associated with heart disease. And we performed the chi-square test and came up with the conclusion that the null hypothesis is accepted, that is smoking status is really independent of heart disease. And we conducted a t-test between the relationship of diabetic and average calorie intakes, and here the null hypothesis is mean calorie intake is equal for diabetic and non-diabetic, and alternative hypothesis is mean calorie intake differs between diabetic and non-diabetic. And after performing the t-test, we came up with the conclusion that null hypothesis is accepted. So we perform the another test called ANOVA test to show the relationship between the average alcohol consumption versus smoking. And here the null hypothesis is mean alcohol consumption is equal across all smoking categories, and mean alcohol consumption differs across smoking category is our alternative hypothesis. And after performing this test, we came up with the conclusion that null hypothesis is accepted. So here is the result of our predictive models. As Bhim already said that we implemented four of our model, that is logistic regressions, support vector machines, KNN, and random forest. So although the random forest has the higher accuracy, we go for the logistic regression because our data set has the imbalance class to our target variable, that is the heart disease. So for the data set having the imbalance class, we look for the recall F1 score and ROC AUC metrics instead of relying on the accuracy only. So therefore, logistic regressions give good value for recall F1 score and ROC AUC. So this is the reason why we choose the logistic regression. So here is the conclusion of our both the descriptive and predictive analysis of our health and lifestyle dataset, and we found the outcomes that smoking, poor diet, and inactivity are the key risk factors for heart disease and diabetics. And we performed a variety of statistical tests that we already discussed in detail. And for the predictive models, we'll look for the metrics such as the recall F1 score and ROC AUC to choose our model, because our dataset has the imbalance class. So we not only rely on the accuracy value, so we go for the recall F1 score and ROC AUC, and we found the logistic regression works better for that value. And after the detailed analysis of the data, what we can offer is actionable insight for public health strategies and personalized prevention. Thank you.
Thank you. Thank you so much.
Thank you. Thank you, everyone.